All right, in this section of notes, we are going to work through a linear programming problem from start to finish. So before we begin, let's kind of summarize our steps. So step one, once you read through the problem, is to identify the variables for the situation and identify the constraints. And remember, when you define your variables, you basically just say what you're going to have x stand for and what you're going to have y stand for. Then once you've defined your variables and identified your constraints, you want to write the constraints as inequalities and then graph each of them. Once you've done that, you can identify the feasible region, which is where all of the constraints overlap, and you can also identify the vertices or the corner points on the feasible region. From there, if you haven't already, you can write an objective expression or equation. And at this point, you can then find the point that either maximizes or minimizes the objective, and there's a couple of different ways to do that. One option is to just test out each of the vertices, so each vertex, each corner point of the feasible region, and you would just substitute that point into your objective expression and you would just work it out. And the other option is to graph one of your objective lines and then use that one that you graph to either maximize or minimize the line. And this is where you might hear me talk about the ruler trick, okay? Lining up your ruler and sliding it either up or down. Okay, so let's go ahead and get started then with an example. So the problem says a farmer who's named Jim is going to plant wheat and rye. The farmer has 10 acres of land to plant on. The seed for each acre of wheat costs $150, and the seed for each acre of rye costs $100. Jim has $1,200 to spend on seed. We also know it takes 1 hour to plant an acre of wheat, and it takes 2 hours to plant an acre of rye. And Jim only has 14 hours to plant this weekend. If Jim makes a profit of $500 on each acre of wheat and $300 on each acre of rye, how many acres of each should he plant in order to maximize his profits? Okay, so first of all, for our variables, we're trying to figure out what combination of wheat and rye the farmer should plant. So I'm going to let X stand for the acres of wheat, simply because it's what was mentioned first in the problem. And I'm going to let Y stand for the acres of rye. And again, we're trying to figure out what combination of wheat and rye will maximize his profits. Now, if you read carefully, you realize we're working with 3 different constraints. One of the constraints is the land that he has available for planting. One of the constraints is the money that he has to buy the seed. And then the last constraint is the time that he has to plant. Now, I've chosen colors here. I'm going to use, when I get to my graph, blue for the land, green for the money, and red for the time. All right, as far as land goes, we know that Jim has 10 acres of land. So when you combine all of his acres of wheat and all of his acres of rye, he has to stay at or below 10 acres because that's all he physically has to plant on. So our first inequality is just going to say x plus y is less than or equal to 10. Now for our money. He has $1,200 to spend on his seed. We know that wheat costs $150 and rye costs $100. So that total, $150 for every acre of wheat and $100 for every acre of rye, that total has to stay at or below $1,200. And then last but not least, for our time, we know it takes 1 hour to plant an acre of wheat and it takes 2 hours to plant an acre of rye, and he's got 14 hours to plant. Now, before we begin graphing, I want to kind of plan ahead and think about where these boundary lines are going to hit. And to do that, I'm going to think about the intercepts, the x and y intercepts for each of our constraints. So first of all, as far as the land goes, if he only plants wheat and that's it, he doesn't plant any rye, he can plant 10 acres. And the same is true the other way around. If he only plants the rye and none of the wheat, he can plant on 10 acres. So our two intercepts for our first constraint are 10, 0 on the x-axis and 0, 10 on the y-axis. Now, as for our money, again, we've got $1,200 to work with, and 1 acre of wheat is going to cost Jim $150. So if we take 150 and divide by, I said that backwards. If we take 1,200 and divide by 150, that tells us that Jim can plant 8 acres if he only does the wheat, so that's our x-intercept. And if we take 1,200 and divide by 100, then if he only does rye, he can plant on 12 acres. So those are our x and y intercepts for our second constraint. Now for our last one in our time, each acre of wheat is only an hour. So if Jim does wheat only, he can use obviously all 14 hours. Okay, so he can plant 14 acres of wheat. Now since rye takes 2 hours, if he only does rye, he's only going to be able to plant 7 acres. So here's our x and y intercepts for each of our 3 constraints, and now we are going to graph those. And I will come back to the objective here at the end. Okay, so starting with blue, which stands for the land that we have available, both of my intercepts are 10, which makes things easy. So let me zoom out here. All right, my x-intercept is 10. My y-intercept is also 10. And obviously I kind of cheated here because I already had my graph set up and ready to go. So feel free to pause the video and do what you need to do here to get organized and get ready. Okay, so that line that you see in blue there, that represents the boundary line for my first constraint. And Jim just has to stay at or below that amount. So I need to take my blue and I need to shade all of this area in here because all of this stuff is fair game. Okay, so that's my inequality for my first constraint. Now my second constraint, and I'm going to switch over to green, my x-intercept is 8, so I'll put a point there. And my y-intercept is 12, so I'll put a point there. And I will use those intercepts then to draw in my boundary line. And again, in this situation, this boundary line represents the maximum amount of money Jim can spend on buying his seed and getting ready to go. So I need to stay at or below this line and I can't go past it. So there's going to be, if I start from the top, this little sliver right here that's just green. And then the majority of it is going to have a mixture of green and blue both. And then as I come down to the end here, I want to make sure I don't accidentally go past my green boundary line. All right, then my last constraint was for time. My x-intercept is at 14, so I'll plot that point. And my y-intercept was at 7, so I'll plot that point. And then I can go ahead and draw in my boundary line. And again, this represents the maximum amount of time that Jim can spend planting his acres. So I need to go up to the red line, but not past it. And so with my red, maybe I'll start down here. With my red, I want to make sure I stay below that boundary line as I shade. Okay, now before we go any further, let me back up here and talk about our objective. So, our objective is that we want Jim to be able to maximize his profits. Now, if we get specific with that, it says in the original problem that Jim makes a profit of $500 on every acre of wheat and a profit of $300 on every acre of rye. So his objective expression would be 500x plus 300y. We want to maximize that combination. So at this point, just because this is a little bit messy and hard to see, I'm going to switch over to a computer generated version of this graph. Okay, it has all of the same type of information, all of the same details, but it's just a little bit easier to see. So you can see we've got our three constraints in blue, green, and red, and then we're trying to maximize our objective expression right here. We're trying to maximize profit. Now, the feasible region is this area that I've outlined in this black. That's where all three of our constraints come together and where all three of our constraints overlap. And the corner points, the vertices, are the points 0, 7, you can see here on the y-axis, the point 8, 0, which you can see down here on the x-axis, and then this point here that's floating, I know it's not hitting a grid point perfectly, but that's the point 5 and then 4.5, so 5 on the x and 4.5 on the y. So we know that our maximum profit is going to happen at one of those 3 points. Okay, anytime you maximize or minimize your objective, it's always going to happen on a vertex. Okay, it's always going to happen on a corner point. Now, if I was doing this on paper, I would probably draw in my profit line. Since that's a little bit more complicated on the computer, I'm going to take my other strategy, and I'm just going to take these 3 coordinates, the 0, 7, the 5, 4.5, and then the 8, 0. And I'm just going to substitute those coordinates into my objective expression and see which of those three ordered pairs gives me the best profit. So some of you might just choose to do it this way all the time just because it's your preference. Again, if I was doing this on paper and pencil, I would probably take the time and actually draw in my line just because that's what I like to do. But this is a perfectly good method as well, and I don't know, depending on kind of how you manage your workflow, maybe it saves you a little bit of time. So if I put in the point 0, 7, I put in 0 for x and I put in 7 for y, I find out that that combination of wheat and rye gives Jim a profit of $2,100. Then if I move along to the next combination, if I put in 5 for x and 4.5 for y, and I calculate that combination and that profit, I find that my profit there is $3,850. And then finally, I have one more vertex that I need to test down here. If I put into my expression, if I put in 8 for x and 300 for y, I find out that Jim makes a profit of $4,000 right there. So out of my 3 possible options, you can see that our last one here is the combination that's going to make Jim the most money. So after all this big long process where we defined our variables, we wrote our constraints, we made our graph, and we tested our points, after this big long linear programming process, we can officially say that Jim would want to plant 8 acres of wheat and none of the rye. So he wouldn't even want to mess with the rye. The rye does not make him enough money to be worth it. So Jim should plant 8 acres of wheat and no acres of rye. And that's going to be the combination that maximizes his profit in the end.